Question number 4. A mass m of a perfect gas at a pressure P1 and volume V1 undergoes an isothermal process. So final pressure is P2 and volume is V2. Work done on the system is considered to be positive. He is saying that work done on the system is considered to be positive. So work done on the system is positive. So if I say work done on the system is positive, the reverse. So work done by the system will be negative. So the work done on the system is considered to be positive. So if R is characteristic gas constant, T is temperature, so work done in the process is. So he gave the initial pressure, final pressure, initial volume and final volume, and he is saying that it's an isothermal process, temperature remains constant, and he gave the characteristic gas constant. And here he is saying that work done by the system is negative, so, and work done on the system is positive. So if I take a closed system like this, so I'm taking some closed system here. So I have some gas. So at some pressure P1 and V1, pressure P1 and volume V1, so I am expanding this gas to a new state where the pressure is P2 and volume is V2. And during this process I am getting some work. So work done by the system we write as PdV. But here he is saying that work done by the system is taken as negative. So if I say work done by the system is negative, I can say this is this one. So this is the infinite small quantity of work that is done by the system when I take the system from state 1 to state 2. So if I want to get total work, so in a process, so it's nothing but minus P integration dV. So here P, so I need to get P in terms of, P is not constant here. If it was constant, I would have taken out of integration. So since P here is not constant, I need to get P in terms of temperature or P in terms of volume, I can say. Now see here, it's PV is MRT. So I can write like this. So for unit mass, I can say PV is RT. I can say for a given gas, R is constant and T is constant. So PV is constant for an isothermal process. For an isothermal process, PV is constant. So I can write like this. So pressure is nothing but some constant, so divided by volume. So work done during this process is nothing but minus, so constant, so by volume into. So if I integrate this one, so minus C into log, so volume is changing from V1 to V2, so it's V2 by V1. So during an isothermal process, P1, V1 is constant. Why? Because, so for a given system, temperature is constant, mass is constant, and R is constant for a given system. Therefore, I can say P1, V1 is equals to, so P2, V2, so this is constant. So I can say minus C is nothing but, so minus P1, V1 log, so V2 by V1, or I can write, so minus P1, V1 log, so P1 by V2. From this I can write V2 by V1 is P1 by V2. So here if you see, option B it's minus P1 V1, so log P1 by P2. Or I can replace this PV with MRT. T is constant, state 1 T is T1, state 2 T is T2, but the temperature is constant, T1 T2 both are same. It's MRT.